All right, ladies and gentlemen, big finish for this topic. Percent yield. You must learn this equation right here. You must learn this equation. But I want to remind you what we talked about off screen, as they say in the biz. If you do a test in this class, you get a score out of 100. Your theoretical yield was 100. The score your teacher gave you was your actual yield, right? So say they gave you an 86% actual yield. Well, your actual was 86. You could have got 100. All right? In our previous activity, you worked out the theoretical yield in two different forms. Okay? You have flexibility here. You can do theoretical yield in moles or theoretical yield in grams. This is entirely up to you. We're going to do it both ways to prove you get the same answer, okay? So in this question, you were given the theoretical yield in grams. Our previous activity, we've got the theoretical yield in grams, 48.44 grams. Is the theoretical yield when 14.61 grams of xylene is completely burned. We did all that work to get that, 48.44 grams. So 48.44 grams, or if you want to do it in moles, how many moles of CO2 were theoretically produced? We got moled CO2 right here. I'm going to go 1.10056, okay? 1.10056. 1.00, was it 156 or just 5? 56. Mole. These are both CO2. Okay? So that's theoretical yield. You can use that one or that one. When you do this equation, all you have to do, make sure the units match. Okay? You can do grams of CO2 actually produced divided by grams of CO2 theoretically produced, or moles of CO2 actually produced divided by moles of CO2 theoretically produced. We have that information on the previous page, and there I copied it to here too. So I think we could save ourselves a little work and do the one where we just take the actual yield. How do you know it's actual yield? It says 14.61 grams actually produced. I will make sure the word actually is in there when you have the actual yield. I will make sure the word theoretically is in the question if it's a theoretical yield. All right. You have to remember it's actual over theoretical. When you're doing a test score, you don't put 100 over 86 to get your test percent. Whoopee, I got over 100%. Well, because you did the math wrong. The 86 over 100, right? Okay. So, long story short, you actually made 14.61 grams. You theoretically could have made how many grams? 48.44 times 100 to make it a percent. Notice the units disappear. If you're doing a percent equation and the units don't disappear, you did it wrong. Yes, ma'am. Yes, I have a student reading the question better than I have. Correct. She said, when 14.61 grams of p-xylene was completely burned, we have a lot of work to do. We don't have our actual yield. Oh, yes, we do. It's right there. Yes, we do. 5.462. Thank you. We don't have a lot of work to do. Sorry, I got to read more carefully. grams CO2. If I had written this down, I would have caught my mistake earlier. Can that be a lesson to you from my mistake? No, it never works like that. Parents will tell you all the time, they will tell you, you're going to do that. You're not going to like the result. But the kid's got to do it and get the result, right? But I'm telling you, save yourself some pain. The teacher made a mistake in class, and if he had written down the units, he would have caught it right away, because I wrote down this number, so I would have been writing 14.61 grams of p-xylene up there, and that's not canceling grams of xylene down here when it's grams of CO2, right? See what I'm saying? I hope. Okay. Yeah. And what you got? It's not a good percent, is it? Let's see, rough ballpark 5/50. That's 1/10. It's better than 10%, but not much. Yes. She doesn't want to give me answers anymore. I feel bad about what I said earlier. 805? Yeah. 12? Okay. And what do we got? Grams CO2 are gone. That's just a percent, no units, right? And it's 11.27 with 4 sig figs. To almost did the same rounding, huh? Yeah. Now the other way is not much harder. What we could do is moles over moles. So if we actually made 5.462 grams of CO2, 5.462 grams CO2 times something that I want to make it into moles. Talk to me. If you're given grams and you want moles, you're not looking at a balanced equation here. You're looking at a balanced periodic table, right? Yes. A very important part of your diet right there. You got the periodic table. I need to get rid of grams and get moles. And we're talking CO2 all the way here. Yeah, the molar mass, there was a reason why I asked for it on the previous activity, because for the students who want to approach the question this way, the one we're doing now, you would have needed it. And there it is, 44.01 grams for every mole. So 1 mole for every 44.01 grams. And give me a number there, please. It's more than 1/10, so 0.1 something. 0.124, and that's going to be mole CO2. So I want to take that number and do it down here. 0.124108157 mole CO2 over, we did the theoretical yield in moles in the previous activity too. Convert moles of p-xylene and moles CO2 to theoretical yield in moles. Oh. Yeah. We all did this all in activity too. So I need moles of CO2. This is what? Tell me what this represents. What was this number? Read the question and tell me what this number was. The amount of carbon, is the amount of carbon dioxide that I might have made or actually made? I need to know which one. Actual yield, right there. This is also an actual yield. It's in moles now. Okay? Mole CO2, actual yield over theoretical yield, 1.0056. You are correct, sir. He said divide that and multiply by 100, and notice the units. Because you made sure they were the same, they cancel out. If they didn't, I really hope it's that number, right? There's never a unit in a percentage, right? There is never a unit in a percentage. You are correct, sir. and verifying that off screen because I want to stop the video.
So if you ever have to